Hello. In this session we will discuss lithium pharmacokinetics. The drug is used for bipolar disorders and mania, and it works by altering sodium transport and the reuptake of serotonin and norepinephrine. It's used for bipolar, alter sodium and reuptake of some neurotransmitters. Lithium is available in several dosage forms as indicated, listed here, but what is important to know is that 150 milligram of lithium equal to 4 milliequivalent of lithium. You need to commit this to memory. So 300 equal to 8 and 600 equal to 16. Absorption. Lithium is completely absorbed. Some sustained release form may have lower bioavailability of 80%. One thing that I want you to know is that the bioavailability that we commonly use is 100% or 1, and 80% for extended release forms. The drug is distributed to body water, and the volume of distribution that we use is 0.7 for normal adult. Some people prefer to use 0.5 for geriatrics. So the drug goes to the body water. The drug is not metabolized, eliminated by the kidney, and 80% is reabsorbed. Okay, and geriatric population may have lower clearance than adult or young adult. So the drug is not metabolized, eliminated by the kidney, and 80% is reabsorbed. The clearance for the population, if we don't have blood level, we can estimate lithium clearance at a quarter of creatinine clearance. The half-life depends on the renal function, but in general, in a normal person, is about 1 day. Therapeutic window depends on acute mania, if the situation is acute mania or chronic maintenance therapy. For acute mania, we start at 0.8 and we can go up to 1.2. For chronic therapy, we start at 0.6 and we can go up to 0.8. Quite often you don't need more than that to have effective therapy. Level higher than 1.5 are associated with adverse events. So the concentration that we desire in milliequivalent per liter is 0.8 to 1.2 for acute mania and 0.6 to 0.8 for chronic therapy. When we draw blood level, we draw a trough before the morning dose, but we need to wait for at least a week of therapy at the same dose or dosage regimen, so we can assure achievement of a steady state. If we want to start a patient on therapy and we don't have level on that patient, i.e. they did not start yet on any dosage, we call this initial dosage recommendation, and we need 4 parameters to calculate the dose. We need the ideal body weight and the creatinine clearance. Ideal body weight is used to calculate volume of distribution, And of course we need to decide what's our goal, what level we want to achieve. The calculations are 4-step process. We start by estimating creatinine clearance for the patient, and we want this to be in liter per hour. Then we multiply the creatinine clearance by 0.25 to get lithium clearance. Once we have lithium clearance, we multiply it by desired concentration to get a maintenance dose in milli equivalent per day. I normally shoot at 0.8 initially. Once I decide the maintenance dose in milli equivalent per day, I convert it to milligram per day by multiplying it by 150, then divided by 4, or 4.26. When we give the dose, we may divide the daily dose and give it every 8 hour or 12 hour, and we order blood level in a week or 2, just to be in the safe side. Now if we get a level and we don't like the level, let's say the level is toxic, very high, or the level is low and we need to increase the level to get a better response, then we adjust the dose based on the measured level. In this case you need several parameters. You need to know what is the current dose, you need to know what is the trough, and if it is a steady state or not. Hopefully it is. And you need to decide what is your new level that you want to achieve. And of course you want to assess the patient response to therapy, because you're treating a patient more than a level. So let's say we get a level. If we have a high level, we can start the new dosage regimen of at lower dosage, but we may stop the drug therapy for a day or 2 until the high level come down. How would you estimate the period or the waiting period? Based on the equation that is listed here, and that's manipulation of the equation that normally used to calculate KE from 2 levels. Okay, so if you have a level C1 and it's declining to a level of C2 and you have the time difference, you can calculate KE. On the other hand, if you have the population KE for a patient, or the individualized KE for the patient, you can, and you have level 1 which is high, and you want to know how long it will take until it get to level 2, then you want to solve for T difference right here using this equation. Okay, now let's get to adjusting the dose. First of all, when you have a dose and a level, steady state level, you can calculate lithium clearance, and this is basically dividing the daily dose over the measured level. One important thing to remember here is that the daily dose need to be in milli equivalent, because the measured lithium level is in milli equivalent. Once you know the patient lithium clearance, which is better than the population, then you can use that clearance to calculate a new dose, and the new maintenance dose will equal to the desired concentration multiplied by the calculated patient lithium clearance. And the dose can be converted from milli equivalent to milligram per day easily, as we previously discussed. That's really basically it with the calculation. It's very simple, straightforward process. Once you recommend a new dosage regimen, you need to also recommend a follow-up process. When would you want the next level? Normally within a week or two at least. And what do you watch for? Response and toxicity are your key parameters. So once again, if you have a lithium level, then you can calculate patient lithium clearance and the new maintenance dose. Okay, patient monitoring, you monitor the levels, and you can read these slides on your own time, and you monitor for efficacy and adverse effect. Those related toxicity are well established. In cases of mild toxicity, where the level may be like 1.2 to 1.5, you will see simple things like tremor and weakness. With moderate toxicity at level of 1.5 to 2.5, you will start seeing confusion, sedation, and weakness. With severe toxicity, you see seizure and collapse. So tremor in mild toxicity, confusion in moderate toxicity, and collapse in severe toxicity. Drug interaction happen at the level of the kidney because lithium is reabsorbed, and some drug can interfere with the reabsorption process. For example, increase in lithium level was reported due to thiazide diuretics, non-steroidals, and ACE inhibitors, or low sodium diet, and increase lithium elimination and lower level was reported due to theophylline. Disease interaction or condition: geriatric and patient with renal impairment will have lower clearance. Pregnancy will have decreased lithium level due to increased GFR. Dehydration result in increased level. Acute renal failure is a contraindication to lithium use, and chronic renal failure result in reduced elimination. In summary, these are the population parameter. Some people say start at 0.5 instead of 0.6. Drug and disease interaction are significant, and you need to be aware of this. Those related side effects are clear and correspond to lithium level, and toxicity may be mild, moderate, or severe based on the level. This is really what we have for lithium, and we can start looking at the study guide. The study guide very much is used to help you practice, and all the answers are provided or can be obtained from the book chapters as we discussed, or in this file. You need to know how to calculate initial dose and how to recommend the dose if a drug interaction is expected. I guess you will lower or increase the dose accordingly. You need to know what are the dose related side effects. Here is a case right from the book, and we'll discuss it. That's a patient who is receiving 300 milligram BID, which is 600 milligram daily. We have serum creatinine, so we can estimate population lithium clearance, and we need to know what is the expected lithium concentration. If we have patient serum creatinine, we can calculate creatinine clearance. If we have patient height, we can calculate ideal body weight to use in creatinine clearance. In the book, a decision was made to use the patient actual body weight in creatinine clearance, because the actual body weight is 72, and the ideal is, if you look at it, for a 5'10" patient, 5 feet 10 inches, would be around 73. So they're very close to each other. Creatinine clearance is estimated at 105 milli per minute and 6.3 liter per hour. Lithium clearance is a quarter of that, at about 1.6 liter per hour. And the lithium dose in milli equivalent per day is about 16, because each 150 milligram of lithium contain 4.06 milli equivalent. The expected steady state can then be calculated, which is equal to the dose divided by 24 hours, the daily dose divided by 24 hours. We multiply the dose by S and F, and in this case we consider both equal to 1. Then we divide the value over lithium clearance, or what we expect to be the patient lithium clearance, and we get a value of about 0.42 milli equivalent per liter CSS average. Now, if the patient level come lower than this or higher than this, and we need to change it, then we need to do different set of calculations. Remember, right here we use population clearance. Even so, we use patient creatinine clearance. We use population lithium clearance of a quarter of creatinine clearance. The actual patient creatinine clearance may actually be different, and this may result in having a level that is not 0.42. Okay? Now, let me illustrate this again. We use population clearance because we did not have a patient level to estimate the actual clearance of this patient, the actual lithium clearance. Now, in question 2, addressing the same case, we have a trough level of 0.5. So that's not 0.4 that we expected. And this tells me that the patient is not clearing the drug as fast as we thought. This also indicates that the lithium clearance is not 1.6. It's probably lower than that, less than 1.6 liter per hour. Okay? So here we have the level of 0.5. But because the patient is still not responding well to that level, we wanted to achieve a higher level. So we need to estimate the dose that is required to achieve a level of 0.8 milli equivalent per liter. In this situation, we're going to use the current dose and level to calculate the patient clearance. Then we're going to use this clearance in the equations that we used early to calculate a new maintenance dose. The CSS average obtained here is the 0.5. The CSS average here is the goal of 0.8. Okay? So let's see what we can do with this data. First of all, because the level is reported in milli equivalent per liter, we need to have the daily dose in milli equivalent. Lithium clearance in this specific patient equal to the dose multiplied by S by F and divided by the reported level of 0.5. The patient getting 16 milli equivalent per day as we calculated in previous screen, and the current level is 0.5, and this makes lithium clearance equal to 1.32 liter per hour. The new maintenance dose that can achieve level of 0.8 equal to that clearance multiplied by the level of 0.8. So lithium clearance times the level. Of course, we consider tau, 24 hours. S and F are 1. Then we need to correct this here. Let me see. This is 1.32. So lithium clearance from here 1.32 times 0.8, the levels that we want to achieve, time 24 hours in a day, will give us a dose of 25.9 milliequivalent per day, which correspond to 957 milligram per day, and we can give it BID. And that will conclude this session. Thank you. You're going to have a case similar to this most likely in the team-based learning activity. You want to know when would you order blood level when you give a new dosage regimen, and my answer will be in a week or so. And if you have lithium clearance, and if you use population volume of distribution, then you can calculate KE, then you can calculate half-life in that patient, and this will give you idea when would you achieve a steady state, i.e. after about 0.5 to 7 times the half-life. You also, if you want to have a complete consultation, you want to recommend the monitoring parameter such as patient response and any dose related adverse events. Thank you.